compounds. There are three parts in chemistry. One is physical chemistry, inorganic chemistry and organic chemistry. Carbon and its compounds come under the part of organic chemistry. Now let us know the electronic configuration of carbon. Carbon has 6 atomic number and 12 mass number. The valency of carbon is 4 and it can form allotropic forms. Allotropic form means the elements which are in different physical forms in nature. Example, diamond and graphite. Chinmay, why the carbon is so versatile?
Because of its property like tetravalency and catenation. Tetravalency it has 4 electrons and catenation it is a self-linking capacity.
And why carbon doesn't form C plus and C minus ion?
Because it is having the smallest nucleus, it cannot gain or lose the electrons, so it cannot form C plus or C minus.
Now let us know about covalent bond. The bond which are formed by the sharing of electrons are called covalent bond. Chinmay, what do you mean by catenation?
It is having the self-linking capacity of carbon that is known as catenation.
It can link in the three types. One is side linking, branch linking and cyclic linking. It can together form 60 carbon atoms. Example, fluorines. Electrons represent with dot is called dot structure. So let us write dot structure for ethane. Before that, let us know about configuration of carbon. It has 4 valence electrons. So let us write 1, 2, 3, 4 dot for carbon. And hydrogen has 1 valence electrons. It needs another 1 valence electron to fulfill its K cell. So let us circle this, and we have to circle these hydrogens. Then carbon needs another 4 electrons to fulfill its octet structure. So by sharing the hydrogen electrons, we can make it octet structure. 1, 2, 3, 4, 5, 6, 7, 8. So we can circle this by making its octet structure. Like this, it can form covalent bond.
There are two types of carbon. One is saturated and another one is unsaturated. Saturated having single bond and it contains blue flame and it contains complete reaction having single bond and its more hydrocarbon is called as saturated. Example, alkane. And unsaturated having double or triple bond. It release blue flame. It's contained in complete reaction having double or triple bond and less number of hydrocarbon is called as unsaturated. Example, alkene and alkane.
Naming and structure of carbon. Structure of carbon depends on the number of carbons. If the number of carbon is 1, it is called as meth. If the number of carbon is 2, it is called as eth. If it is 3, it is prop. And if it is 4, it is but. If it is 5, it is pent. And if it is 6, it is hexa. If it is 7, it is hepta. And if it is 8, it is octa. If it is 9, that is none. And if it is 10, it is deca. If carbon is having single bond, then it is called alkane. And if carbon is having double bond, it is alkene. And if it is having triple bond, it is alkyne. Now let us know about the structural formula for methane. Methane is a combination of meth plus N. Meth means the number of carbon is 1. So here we have used 1 carbon. So it ends with ANE. It means carbon is having single bond. So now satisfy this carbon with hydrogen. Methane or methane cannot be formed because carbon cannot form a double or a triple bond with hydrogen. The first member of alkene is ethene. Ethene is composed of 2 words, that is eth and e. Eth means number of carbon atoms are 2 and it is satisfied with hydrogen. And e means it is having the double bond. This is the structural formula for ethane. Ethane is composed of 2 words, eth plus ine. Eth means the number of carbon is 2 and it ends with YNE. So carbon has 3 bonds. Now satisfy the carbon with hydrogen. Bhavna, how can we know that hydrocarbons are saturated or unsaturated?
By using the general formula for alkane, alkene and alkyne. By using this formula, we can know whether the hydrocarbons are saturated or unsaturated.
that methane is saturated or unsaturated. The chemical formula of methane is CH4. Here in this formula N defines to the number of carbon. So C into H2 into 1 plus 2 that obeys CH4. So here methane is saturated. In the same manner we can find for ethene and ethine. Now let us know about the structural isomers. The hydrocarbons having same molecular formula but different structural formula are called structural isomers. And here is an example. This is an stage link for C4H10. And this is the branch link for C4H10. And this is a cyclic link for benzene. Benzene is the aromatic hydrocarbon which is having different kind of smell. Let us know about the functional groups. The groups which decides the chemical properties of hydrocarbons are known as functional groups. In functional group, hydrogens can be replaced by other atoms. Those atoms are called as heteroatoms. Here there are 5 functional groups that are halogen, alcohol, aldehyde, ketone and carboxylic. So now let us know about the halogen group. The prefix would be the 17th group elements called chloro and bromo. And the suffix would be the name of hydrocarbon. There are 5 functional groups that are halogens, alcohol, aldehyde, ketone and carboxylic. So now let us know about the halogen group. The prefix for halogen group will be the 17th group elements like chlorine and bromine. The prefix will be used as chloro and bromo and the suffix would be the name of hydrocarbon. Now let us have a structural formula of halogen. In the functional groups, writing structure of functional groups, the functional group should be attached with the first carbon atom. This chloropropane. A structure of chloropropane. Prop means 3. So here we have used 3 carbons and chloro is attached to the first carbon and now satisfy the carbons with hydrogen. The next functional group is alcohol. The symbol of alcohol is OH. Here the prefix will be the name of hydrocarbon and the suffix is OL. Now let us know about an example for alcohol, that is propanol. Prop means 3 carbon atoms and nol means it belongs to the group of alcohol, so it ends with OH and satisfy those with hydrogen. Functional group is aldehydic group. The symbol of aldehyde is COH and the prefix would be the name of hydrocarbon and it ends with the suffix -al. Here is an example for aldehyde, propanol. Prop means 3, so we have used 3 number of carbons and now satisfy the carbons with hydrogen, and as it belongs to the aldehydic group, it has 1 hydrogen and 1 oxygen with double bond. The next functional group is ketone. The symbol is C double bond O and here the prefix will be the name of hydrocarbon and the suffix is -ol. Now let us know one example for ketone, that is propanol. Prop means 3 carbon atoms and the symbol of ketone, that is C double bond O, should always mention in the middle and satisfy the carbons with the hydrogen. Here the example for ketone group is propanol. Propanol means we have taken 3 carbon atoms and the C double bond O should always be in middle and satisfy the carbons with hydrogen. The next group is carboxylic group. The symbol of carboxylic group is C double bond O single bond OH and the prefix would be the name of the hydrocarbon and the suffix would be the oic acid. Here is an example for carboxylic propanoic acid. Here prop means 3. So we have used 3 carbons. Satisfy those carbons with hydrogen and as it belongs to the carboxylic group, here we have double bond O and single bond OH. Now let us know about the homologous series. The series in which hydrocarbons having the same differences in CH and in between consecutive series is known as homologous series. Here is an example CH3OH and C2H5OH. Here there is a difference of 1 carbon and 2 hydrogen. Now let us know about the chemical properties of hydrocarbons.
Let us know about combustion, burning of hydrocarbon in the presence of oxygen. by releasing heat, light and carbon dioxide is called combustion. Example, C plus O2 gives us CO2 plus heat and light, and CH4 plus O2 gives us CO2, H2O and light and heat. CH4 is a methane gas which is used in our kitchens.
Let us know about oxidation reaction. The adding of oxygen for combination process is known as oxidation reaction. Example, when ethanol is heated in the first form of KMNO4 gives us ethanoic acid. Here hydrogen is displaced and oxygen is added. This is known as oxidation reaction.
Substitution reaction. One atom can be replaced by the other atom in the presence of sunlight is called a substitution reaction. Example, CH4 plus CH2 gives us CH3, Cl plus HCl.
Addition reaction. Adding of hydrogen in the presence of catalyst to convert unsaturated hydrocarbon to saturated hydrocarbon. Here it is example. And addition reactions happen in only unsaturated hydrocarbon.
Let us know about the properties of ethanol and ethanoic acid. Ethanol. It has a melting point. It belongs to the group of alcohol. It does not react with the carbonate and hydrocarbonate. Yashaswini, what is the reaction of ethanol with the sodium?
Ethanol with sodium. Sodium plus ethanol gives us sodium ethoxide plus hydrogen. Now Shree, what is the reaction of ethanol to give unsaturated hydrocarbon?
Heating of ethanol with high concentration of sulfuric acid gives us ethane reacted by dehydration of ethanol.
Properties of ethanoic acid. It has less melting point. It belongs to a group of carboxylic acids. It reacts with carbonate and hydrocarbonate.
Esterification reaction.
The reaction in which ethanoic acids reacts with ethanol to give ester plus water. Reaction ethanoic acid plus ethanol gives us ester plus water. Now yes, you want the saponification.
Manufacturing of soap is called saponification.
Reaction ester with sodium hydroxide gives us C2H5OH plus CH3COO. Reaction of ethanol with base.
Sodium hydroxide plus ethanoic acid gives us sodium acid plus water.
Soap and detergent. The soap is dissolved in water. It forms many micelles. It has two types of. One is hydrophilic, and tail is hydrophobic. It has attached to the water, tail was attached to the dirty. When we rinse the cloth, the dirty